Okay, so I'm back with Spring 2020 Exam 2, Dynamics, problem number 4. And the first time I worked through this, I talked about we could find acceleration by summing forces as mass acceleration, or we could start with velocity, 1/2 mv squared plus the sum of force distances equals 1/2 mv squared. Okay, so this time I'm going to work it through finding the velocity and then going back and finding the acceleration. Okay, so the first thing I'm always going to do is draw myself a free body diagram, and here's my box. And I'm moving up the ramp, so that's my x direction, which means y is having to come in this way. So I have a normal force, I have a force of friction, and that is 0.18, that normal force. And then I have this mass that's being pulled by gravity, and so I have 30 times 9.81, and again this is 20, so this is 20. So if I want to look at over here, then here's the x, here's the y. I have 20 times 9.81. I have a 20 degrees here. Wait a minute, that's 30. I have 20 in my brain because of the angle 30. Okay, so I mean, so this y component is going to be 30 times 9.81, sine 20. Okay, and over here we have 30, 9.81, cosine 20. Okay, so that's how we're breaking this guy up. And here we have the same thing. So if it parallels, if this is 20, this has to be 20. So when I look at my force coming in, okay, I'm looking over here, sine, okay, if I'm looking over here, I'm going to have sine, and wait a minute, that's not drawn right. I can fix this. So I'm coming in this direction, parallel, this has to be 20 degrees. Because this is not coming down like that. It's coming down like this, perpendicular. Okay, it's perpendicular. So these two, so I'm going to have sine and cosine. Okay, so I have F cosine theta, and then F sine theta coming down. And again, if I want to draw these in color, then my y direction is in this direction. So I have that normal force. I have the force pushing down. And then if I come over here and I'm looking at the y, it's that side. And if I'm looking at x, which is going in this direction, I have x component, x component, x component. So I have everything broken down and it's even color coordinated. So it doesn't matter which way we start, we're going to have to figure out the normal force because we have friction. So we're going to sum our forces, mass acceleration in the y direction, okay? And I know that has to equal 0 because again, I'm moving up and down the box, I'm not moving in the y direction. So I have some of the forces in this direction, and I'm going to start here, so I have normal, minus F sine theta. So I have 275 newtons times sine 20. And then I've got minus 30 times 9.81 times, blue is cosine 20, equals a big fat 0. So if I do my math correctly, it should be 370.6 newtons. And that is my normal force. So now if I want to go back and I'm looking at this box moving up, and I'm going to start with the force. I'm going to erase all of this for just a minute. And we are looking at the x components that are moving up. So if I'm looking at the x component, okay, there's my x component, F cosine theta, and it is moving up the box, up the ramp. So I need to know what that distance is, which I can find again by, I have a right triangle, sine 20 equals, so 14 over length of the ramp. So the length of my ramp is, I think it's like 40 40.93 meters. Okay, so S for my force, S is going to be 40.93 meters. Now I'm going to look at a different color just so that, because now we're looking at distances, it might be easier for you all to see if we have different colors for things, what we're doing. So when I'm looking then at friction, friction is going in this direction, and it's the normal force, 370.6 times 0.18, my coefficient. Okay, I also know that S is working. Okay, this force is working over that distance S, so it's also 40.93 meters. Now, when I go back to look at gravity, remember gravity is independent. Gravity is literally that y direction. So this is our distance for gravity. And because we are looking in this direction, we look at the entirety of the 30 kilograms times 9.81 because we're looking at this shorter kind of distance. Okay, so let's get this set up. If we are using potential kinetic energy or work, we have 1/2 mv squared plus the sum of our forces times their unique distances is 1/2 mv squared. And I'm starting from rest. So now I'm going to look at, okay, I have F cosine theta, so I have 275 times cosine 20, and its distance is 40.93. Okay, that's positive, minus friction, 370.6 times 0.18, so that's my force. And its distance is also 40.93, minus, okay, minus mgh, okay, equals 1/2 mass is 30, velocity at the top of the box squared. And if I do my math correctly, then I get that the velocity is 15.76 meters per second. Okay, 15.76 meters per second. And if I go back to part 1, okay, part 1, where I did this using force equals mass acceleration, I came up with an acceleration, and then I used kinematics, and I found a velocity. And lo and behold, I got the same number. Okay, so how would I go back and find acceleration? Well, I've got V equals V naught plus AT. So this is a 0. I don't know acceleration, I don't know time, but I do know this is 15.76. Okay, I have S equals S naught plus V naught T plus 1/2 AT squared. I'm starting at 0. I have 0 velocity. S is 40.76 or 40.93. I don't know A or T. So hopefully this last equation, okay, hopefully this last equation will get it for us. So I know that my final velocity is 15.76 squared has to equal 0 plus 2a times 40.93. And I can go through now and calculate A. So I have 15.76 squared, okay. And now I'm going to divide by 2, and I'm going to divide by 40.93, and I get an acceleration up that ramp of 3.034, which is super close to 3.035 that I got using the other method. And once I have acceleration, I can come back in here and calculate time, and I can check to make sure that everything works out. So that's how you would work this using work. It's just the same thing, you just have to pay attention to your distances, okay? So I hope that helps with the color so you can see what it is, the distances that we're using.